Hello and welcome to the episode 8 of Code Deep Dive with OpenTTD. In the last episode, we started looking into how the new world is generated, and in this episode, we will just continue that. There's still a couple of things to set up. If you find presented content useful, don't forget to press the like button and subscribe. So after the initialize game was called, there's yet another function which is prepare generate work progress. And this seems like the some status structure for word generation simply, which stores the percentage, how much is done. There is also something like the string ID referenced, so probably which will be progress will be somehow displayed in the UI. Okay, so there's some check on the construction with regard to map height. Let's see what it says. It checks variety of modes. Okay, so it's empty. Okay, estimated height there. Not sure what's that, but apparently it's the objective is just to set this map height limit. And there are some defaults here, like 30 and max tile height 255. Okay, can you check that? Okay, it's set up to 30, and we have some generation seed, which is actually 0, so this would not be triggered. Okay, and then we have the load sprites. You can see in the console what does it says. Loading sprites at 0. So landscape type is temperate, Arctic, tropical, Thailand. So temperate is the classic one. It's probably shown in the welcome screen. And then there's a switch to new GRF blitter. Blitter is auto-detected. For null driver, it will just exit, but we don't have null driver. We should have like 32 screen depth. And then we see here that the base wants the 8 bits, and then the gref should be 32 probably, yes. And then we have gref config, which is empty actually here. What's that? Get font state. Global AA. Oh, so it's a check if we want to have the anti-aliasing. Okay. And then we have this definition of structure here. Animation, support, name. And then there's some set of blitters of this type. And we check if there's a default animation bit set in display option. Perform palette animation, okay. Animation wanted. Okay, it's set to true. And then we have the blitter, which is our 32 BP animation blitter. And then we have also replacement blitters, which is this, okay. And what's here? If the animation is wanted and animation is 0, it's not this. If the animation is not wanted, it's inside. So essentially what this block about? So so we want to get here and we want to inform the video driver we should switch blitter as soon as possible, if that's the case. So either here because all this, mainly this condition probably fail, so we'll not see it here or here. So let's see. Okay, so we get some replacement blitter, and it supports animation and this SSE2 animation. Okay. Okay, so we kind of bend it. I want to bend it to driver. Sorry, no, we don't bend it to driver. We queue it on main thread with via driver. Okay, here it is. So we have this function. And this is, yeah, real change blitter. So this is the function to be called, and this will be queued on the main thread, and we just bend it with this parameter. Okay, so what happens here? There's a log guard, and there's this NVIDIA driver has a command queue mutex. So it just guards the queue, and the queue is just the vector of the functions. So what we do is we just put this function into this queue. Okay, we can just for the future, we just put a breakpoint here. And okay, so this is set, and then we clear the system sprites in the video driver, and this is empty by default here, seems. Clear font caches. Yeah, we saw that in some previous videos. And then we init sprites memory. So there's a sprite cache global variable which can hold many sprite caches. And one sprite cache is actually just a pointer to byte array. And then sprite temp length of sprite data. And then we have different sprite types, which could be like font or map generator sprite and the normal one. So at the moment it's empty. Let's just double check that. Yeah. So it's being cleared, and sprite files. Just a random access file. Contains the different types of data. Okay, so it's just kind of abstraction on top of the file. Okay, so so this init was actually the clearing, just resetting everything to empty stuff, and then there's like load sprite tables, and we pick the graphics set, and in set we have like GFT base, so you can have like many files, and then we can load this GRF file. Okay, so yeah, so check that. It's actually okay, because it's like reference, so cannot see. It's not really displayed well if it's a reference. So, but let's check one by one. So sprite ID is just the integer of the sprite, and here is like 0. and then the load index is also 0, and then we open the cache sprite file. With no need palette remap. Let's see, we'll get by name. Okay, and this seems like we have just global sprite files. Which is empty anyway. So so this should return null. So in that case, we just insert at the end the sprite file of this file name and base a directory. So let's see, can we check what how the sprite file is constructed? Is there anything special? Well, no, it's probably nothing special. So just get some container version and position of the file. That's how to read that. And then the sprite file is returned. So random access file, and as we see, we just have an information where the content begins, some kind of the version as well. And then it's like a file name and the buffer and everything here. Okay, and here we can see that we are reading this OpenGFX file, the base one. And there's some container version, which is still. And next we read some offsets. So we read the word, double word actually, from the file. We can see how the reading is implemented. So we just read the word, read byte. Then there's like a buffer, which is, what's the buffer here? Okay, it's just like current position within the buffer. And okay, we can just increment this and just return the next value. And then, okay, we just read another byte and just shift it by 8 bits and just make a bitwise OR, so to get like word and the same with the D word. Right. So this way we just read like 42 bits, so the data offset. And then we can also get the position, which is like position the file of the end of the read buffer. So it's probably where we are in the file. And this is where we are with the buffer, where the buffer is pointing. How would it work? Then we just read from the buffer. That was my impression. But then here it's like 0. And here is buffer and in the case we seek to this position that we read, so the offset of the file. Maybe it will just show how the position is changed. Yeah, the mode is actually seek current. So we'll get the current position, which is just a position value. And then we add the current position. So this position is actually current position plus the offset that we just read. And then we just do the file seek, because we have like a file handle here. And then the buffer is actually set up to buffer end and buffer start. Okay, so there is a buffer start actually. It's like a header, the gref header. And then we declare the offset. The offset is just file position and some control flags. And then we read another double word. And for example, here we have like 1. So, and then we say, okay, we store all the offsets for the sprite. So the previous one was 0, and then we just say, okay, here we have this first offset, but then we just get the position -4 because 4 bytes were read, and the control flags are reset. Okay, and the ID is updated, and then we read again the word, the double word. Then we see that there's length like 138, and that's the case. So we read the color from the file, and this is like enumeration bit set, RGB alpha or palette. In this case, it's like 4. Okay, it doesn't seem like there's 4 here, or am I reading that right? So we decrement the length because we read just the color, and then we have the zoom, which is 0 here, and we decrement the length because we read the bytes, and then zoom was 0 and color was any. Oh, so maybe that's this any. And then we set the control flags. And what it means here is that if it's not palette, then allow. Okay, so there are some control enumerations that says how, probably in which magnification these sprites can be used. And then we just skip the bytes, so we're not reading the sprite apparently. We're just going one by one through the sprites, and then yeah, yet another length, and yet another byte read. Okay, and this is any is true and zoom is 0. Okay, that's so it's just that the color has any value, which is 4 here, whatever that means. Okay, so I assume that once we have that, so we have like a, so we fill basically this GFR sprite offsets here. We have all the informations. So this is like a the map that just contains all the offsets of all the sprites, and it's like indexed by their ID. So we know where the sprites are in the file. We start just the last one, and we just seek to the old position. And here is like a seek set, which means that The mode is different. We just set the position as it is. And here it is. And then the buffer is restarted. I don't know if I still read how this works. Okay. So we have all the offsets, and then we check if there is a compression, but by default it's none, and that's good. And then we are loading the sprites actually, so that's how I would read that. Load next sprite. So we get the position, and we get the position in the file, like this absolute position. And then we read double words, and we have like a 4 num. Does it mean like it's like number of sprites or something else? We have also grf type, and then this grf type is 253. So it's exactly this one. I should just get this. And the num is probably just kind of this 4 is probably some magic number. If it's not 4, then it's in the sprite section. And then we just, so we're again going through the file. We just know the offset, so we just read the offsets here. And we just find the file, the offset, and then we have like a file position and control flags from the iterator, and we know that's normal sprite type. This is some control if we have loaded more than sprite than allowed. How much is it actually? Sprite width. Okay, that's a lot, like 1 million probably, or 16 million. Then there's some check for mapgen sprite ID is inside mapgen begin and mapgen end. Okay, again some magic numbers here. Okay, so this is some special sprite, and we just check if this sprite is between these two values, right? Okay. Yeah. Why is it done this way? Check if value is in an interval. Okay, so just one. Oh, because they just want to like do one comparison and a subtraction here. Hey, it can be done this way as well. And this is probably false. If it was not, if it were not false, we will just set the type to mapgen, and then allocate sprite cache. Maybe I should check that. What was that? So for given index, we just do some alignment, and we just resize the cache. So just prepare for yet another sprite cache. And here we just say that, okay, let's attach this random access file, and then we have the position, and we have the sprite ID, we know what the size is, and so on. Yeah, and we just go over and over the file, because this is now incremented. We just see that it's just a new position. What I'm wondering is that it doesn't seem like we really load something here, a part of the offsets. So we go here and here. So let's see. Sprite cache. So yeah. So in this sense, this file just maybe the file is okay. I think I'm getting that. So this file is actually has everything loaded in. It seems like there's this buffer idea, or at least, well, we have this position here. So maybe we can just do this random access, and it already had something in the memory. And this is how the cache works. Okay, anyway, we just iterate through this loop, and the cache is growing. And then we see that currently for over 4,000 sprites are loaded. Okay, so we have this GRF file, and then we have some special GFT logos. But I think it's also a load GRF file. It's just that different type. Different type of file is used, and different sprite ID. So I think we can just skip that. And then we have, for something which is, so for different landscape, we have probably some customized sprites for the Arctic, for example, set up. And then we have Unicode glyph math loading. We have character maps. Oh wow. Oh, it's like an array of unordered maps where we have a sprite IDs. So for each character we have a sprite. And like there are different maps for each font size. So for each like ASCII, we just get the base, like the sprite ID, and then we check if this is contained in the sprite cache. So the sprite cache should be read like this. So we have a global variable. Yeah, the vector with all of these caches. So here's the byte pointer. And we just get the reference here. So the 5 position is 0 and the file is null pointer, then it's not there. So what here we see it probably exists. Yeah. And then we say set Unicode glyph. So for this particular sprite. So we saw that map. So this gives for the given font size and given key type, we just set the sprite ID. So we just say, okay, if you want to use this character, use the sprite. And here additionally, SCC sprite start string control code. So it's additionally something special is stored here. So the same sprite is stored twice. And we go over the whole ASCII set, or even wider. And then we have the Unicode map as well. I would say there are some special characters, not many of them actually. Middle dot, microsign. feminine and ordinal indicator. And then we also check if it exists, and we just use the Unicode map to just set up the sprite. Okay, and that's that. So we can exit. And then we just iterate through all the font sizes. So there are a couple of them, small, large, mono, and so on. Okay, what we see here is that we read the config of grf. Oh, interesting. Information about grf. I think we haven't seen that. It just contains the file and our information, like some identifier, hash. And then we said we filled grf details from the base set. Load new grf file again. Oh, it's just annoying. Why cannot I see that? So it creates some temporary sprite file, and then okay, it's 11 characters. OpenTTD grf. Okay, and now we load this from load new grf file from file. It's actually output. Why it's gone? I don't see the output here. Okay, it's a bit sad. Something was broken. So the stage is JS file scan. Okay, again, compression. Have we seen that? It's very similar to what we were been going through. GFR processing state. So this introduces some sprite set and actually gives us this sprite ID. Okay, sprite ID of the first sprite of the set, and then number of sprites in the set. And this will probably just clean the stuff. NFO line. Okay, a lot of things about the sprites, about like identifiers, references, file references, config references, buffer references. I think going through all of the tests may be a bit too much, and we just blur the picture. That's what I feel. But just to get the rough idea what it is, and no, that's what goes where might be important later. And here we just say that okay, this container version is always 2 as we remember, and then we have this num which is 9 here, and then we set the type, and the type is like 255, and then we say skip sprites. What was this one? Oh, processing state. Okay. Limit the special sprites. Decode special sprite. So we're in some special sprite mode. Initial decoding of some special sprites. Oh, okay. Some danger zone. And this is gref line to sprite override, some global. I'm not sure if there's anything in this. So we just allocate, there's some allocated, and it allows to allocate things like reusable buffer. Okay, and then there's like a, we can just get the buffer out, and then this current JR file, we can just read the block. And here we see how we read data actually from the random access file. It's just that we read it to this buffer, and what happens here is that we have the pointer here, some starting pointer, and the buffer end, and we just, first of all, we take the amount of data to copy, and this should be 9 bytes, I guess. And then we copy to this buffer this amount of 9 bytes from this into this pointer, but from this buffer, from this place. And then we just shift the buffer. And we know that's all, and we return. And apparently, as we see here, so we have something in the buffer, and if we didn't have that, we would just, it seems that it would just read from the file if there's nothing left in the buffer, in the block. So now we have this buffer, and there's like a byte reader. Let's see what the byte reader is about. So it accepts a buffer of data that we just read, and we have a length of 9 here. And then it initializes the consumer here of this data of this specific length. So now when we read the byte, it just asks consumer to just read the byte from this specific area of data. And then we just get the value. So the first byte is 7 in this case, and then there are some special actions to be checked. And if these are not there, then we just invoke action handler. And we check if it's within range, and we pick a function, the invoker, that handles this action. And in this case, this is this invoker. We get this buffer, or specifically the byte reader, on top of the memory. And the stage here is file scan. So this is the file scan action handler. And here we have templated function. So as we see here, there's like a definition of the templated structure. So actually, this is the byte we scanned. So the value of 7, and then this particular action handler doesn't do much. So this way we just scan byte by byte, and then each byte can have some action assigned. It's just that it's not necessarily that will track actually something meaningful. So now it's /v, which is just 11, but here for the file scan doesn't happen much. I'm not really sure which actions actually do something about it. For example, here we could suspect that this will do some skipping, for example. So to read byte, and then it will just skip certain amount of sprites, this action, somehow by just ignoring type byte. but this is like all about what this format GRF format is about. I think it could take just another series to just speak about this format, I believe. So maybe I would just skip that. Maybe it deserves just another episode. In any case, we keep reading the GRF and then just decoding the sprites. We could check that if the type is different, then maybe something happens here. And in the case, at some point we'll just exit. So we'll just go through the whole file. That's a bit of a pity. I really would like to see what's some meaningful action. All right. So here we have another type, and then what is that? This is some processing state, and then can we check this? All right. So the skip sprites is not 0. Then somehow for the container version greater than 2 or equals to, and the type, which is actually 253, we just skip some bytes. That's probably just about how this format is handled. Yeah, and then it goes on and on. Okay, so maybe let's return from here. At this point, it seems that new GRF file is loaded. And then there's a stage which is probably, okay, it's label scan. So we skip that. And so what is that? So we have some config here. And then this is just a pointer. Just a pointer to config. Okay, so if the status is disabled or not found, then we just continue this iteration. And then if we are later than init, which I think we are, and then we just test for the flag here that it's just init only, then we will also skip. But here is how something else happens. So we check the subdirectory, we pick the subdirectory, and then we check if the file exists. That sounds like a sanity check. And then we we keep going through the next config file. So so again, loading. We won't get into this. I think there were 2 files, so this will skip here. And then we go through the other stage, which is now init. So okay, so there was like label scan. Okay. So for each stage, there's like a different things happening. So now it's init. So I'm wondering if we will get something new here because the stage is different. So let's just jump here. And we have seen that. And we load from file. Get cache sprite file by name. That's fine. We just seek to begin. Oh, okay. I think I skipped too fast. All right, so once again. So we load again. Not the temporary. Load new GRF file from file. And then exit here, but enter here. Okay. And we have seen that. And then the stage is init. Read grf sprite offsets. So we clear the offsets, which I guess is in a way the global here. We check the container version and then read the data offset and the previous position, and we just seek to the new position, and then we pick up the word, write some offsets, and again, then there's some color we read, then if there's still some data, some zoom information that its sprite probably applies to, and then the rest of the bytes. Skip is probably the content. Okay. And we probably process all the sprites here. And we just have all the offsets in place, and then as I imagine we just set this global array to the offset, so just to remember the position. Okay, what else? Check for compression, because it's not supported here actually. Then we skip some word, double word actually. Clear data for next file. Okay, yeah, so clear the structures for that read data. And here we should actually get to the coding of the sprite again. It's just that now what I assume would happen is that we'll have a different actions. Maybe I'm wrong, but let's check that. Right, so here the stage is different, so there's different action. So, but yet it's still empty. Right, it's again, it will be difficult to scan that. So we had like a file scan, there was label scan, init, reserve, activation. I was wondering if there's something that interesting that could happen here. For example, for init, if I pick something random, oh, here's like a sound. Let's create a sound. Skipping, I guess it's creating the sound. Skip. Is anything happening here? Config apply. Skip. Load error. Okay, that sounds interesting. Feature downame. So how about getting rid of this bulb and just give it a go. All right, so actually the activation was cut up. It is like a different action here. So maybe let's see where we were. So the stage was, yeah, we fast forward to activation actually. And then what happens with this handler, it creates, is it like, no, it's a function. It calls new sprite group from the buffer. And then it says that we have something different in the buffer. So 002 is actually that the new sprite group is probably created. So we read the byte here, which is here the enumeration. So GSF canals. Huh, interesting. Yeah, and then we have some IDs and type, and then we see that it's not any special type. The type was here was just 1. And then we switch the feature. So for canals, as for any other things like road vehicles, trains, actually the same. So number of probably loaded. So okay, number 1. We check if it has valid sprites, what it is. Okay, so some sanity check. And then we have like a new sprite group to be loaded. Some conditional checking. Okay. So nothing is loading yet. 1 loaded. Sprite ID is 0. So how does it look like? So we get the sprite for canals and sprite ID is 1. The question is that if there is a sprite there. It seems to be. And then we just get like a num sprites 12. And then we check if we can allocate the item, which we can just, we check the pool. So, okay, so there's a counter and the max size. Yeah, probably a lot of space. And then we create actually the sprite group. So we get the new thing from the pool. And we look up for the first 3. So here we have a bitmap, so vector of bitmap storage, and we go through this. Oh, interesting. Okay, we revert that. And then we calculate the distance from this one. Okay, I'm not really sure what's happening here. So the first set bit in a value when no bit is set, it returns 0. All right, I remember this one. So this actually gives us the first index in the pool, I guess. And there's a special no free item, which is not the case. And then we say, okay, first free index is increased to 2, and then we allocate 24 elements at index 2. What does it mean? So we check it's empty just for sure. And then first unused is actually the second one. We increase the items to 2. And then what's that? Okay, it's a template for that. Apparently it's false. But okay, not necessarily, but because allocache is null. But here we can just use allocator, which is new allocator, and just we allocate 24 bytes, and we just get this as a t item pointer. Okay, this item is stored in this data pool, like data. Yeah, so this is like at index 0 we have a pool, and this pool now contains some index, I guess. Then we also check, we just set bit for used bitmap. There you go. And we return the item, so the pool, and we cast this index to t index. Okay, and once we have that, the new operator is called. So we have this memory allocated in the pool, and then we just we just use the index information just to create the object in the pool, which in this case, I guess, is the sprite group, I guess. New sprite group, one result, skipping real sprite group, real sprite group. Okay, and then we break. Okay. So that's the activation example. So it seems like there are different phases of scanning GRF. So like some initial phase just to get some idea on what's inside, and then some initialization of some structures, and then to activate that to do something real with the data. Yeah, and we are here. So and once all the items in the GRF are loaded, then it's considered like done. Here's something interesting, build cargo translation map. So get some table, all the houses are here. And then we iterate the cargo list. Okay, and we just set for each CS, for each specification. Hold on, what's that? Mask. Okay. Okay, this is I'm not really sure what it is, to be honest. Translation map. This is the reverse of a cargo translation table. Okay, so we get from the index, like CS index, cargo spec index, to yet another index. So in cargo list, we search by label, and I think it's like a natural way of looking up things. And we just built kind of a reverse map. Okay. And I think we have seen something in the terminal. Have a look. So you see, for actually a lot of groups are created. The code special sprite handling, we saw that. Config applying for bytes. Decoding special sprite, yeah, some skipping. So all that happens here. And once we're done with all the stages, well, this global structures for loading are cleared. There's some after callback, reset callback, finalize string mapping. Okay, a lot of finalization, a lot of small functions. I'm not sure. Get badge by label. Add badges. What is badge actually? Okay, it's empty. Okay, maybe there's something interesting here, but not really. I feel like this structure is still empty, and this is just cleaning up stuff which have been running. So I will risk going in here. Okay, just checking some route type. Right. And then we are just reverting some dates, counters, and that's that. And here we just count the number of sprites. So If sprite exists, then get it from cache and just count that. Let's see how much it is. How much sprites are there? 124. And oh, there's some like missing extra graphics. Interesting. The original base set extra graphics intentionally make use of the fallback graphics. So this is probably some legacy handling, legacy behavior handling. So I would not bother about it this one for now. So the last thing about loading sprites is like update cursor size. I think we've seen that before. So I won't get into this. It's about the zoom probably and things like this. So it's about the zoom and things like this. So I think we can be done for today. There's still something about word generation, but this is maybe to be covered in the next episode. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.